Notion is a collaborative documents product. We are very similar to things like, like Google Docs. And the way we model document sharing is through the concept of a block. Each one of these things is its own block. So you can see images, text, headings, toggle lists, tables, collections, and stuff like that. So all of these things are actually modeled on the back end as the same entity, even though they visually appear very different. Before 2020, it was actually quite simple, right? So many startups go through this phase of single Postgres instance. Everything on the app runs against this single Postgres, and whatever analytics you have at the time also works off of the single Postgres instance. Fast forward to 2021, we actually brought up a data warehouse, a formal data warehouse architecture. So it's fully productionized and everything, where we were doing analytics and reporting. This is kind of like the stack that we use to Postgres, ingest via fiveprint into Snowflake. So fairly modern. And then we kind of use Snowflake as our data warehouse to power analytics reporting and a bit of machine learning at the time. This architecture worked well for a little bit, but our block table actually was the most difficult to deal with because it was sort of the largest and fastest growing by volume. And we started to see problems with fivetran that we couldn't really resolve on our side by ourselves. The per hour incremental syncs obviously started to fail. A lot of ooming, actually, a lot of issues handling bursts of volume. More importantly, I think we couldn't actually do anything to handle variation in like block update volume, right? So, it's fivetran is kind of like a third-party product, and there's few knobs that we can actually tune. The load into Snowflake was also challenging to deal with, mostly because of cost, actually, because loads into Snowflake actually took quite a long time. Sometimes it actually bleeds over the sort of like the hour SLA that we have, but also it's very expensive to actually load something like, like several tens or hundreds of terabytes into Snowflake, in aggregate day over day, right? Hudi actually has pretty good integration with Postgres. There's out-of-the-box CDC, basically, the Debezium connector that we could just simply deploy. So what we did was, eventually, we essentially just deployed Debezium on an EKS cluster and had that listening to the wall through Postgres replication slots, which we already set up already for fivetran, right? So a lot of our existing infrastructure was already configured for that. We already knew how to do that, and Debezium was already sort of provided to us. We saw actually really good open source velocity, and we already had relationships set up basically internally with OneHouse. So early members of our data platform team actually, worked closely with the OneHouse team, and we thought that was invaluable for us being able to get up our data lake architecture in a fairly short amount of time. Our open source relationships with OneHouse was actually really essential to the success of this of bringing this technology to Notion. The ability to kind of just not have to engineer, like reinvent the wheel for a lot of these components was really valuable. We saw a pretty good net saving, about 1.25 million a year. It actually improved fivetran performance overall for us. So other tables weren't so, like heavily affected. If we needed to conduct full resyncs, that wouldn't take, multiple days. That would just take a couple hours. Historical fivetran resync also could be done on a regular basis. Today, our Delta streamer is configured to run syncs every 4 hours. We could obviously actually go even more incremental, but for now, basically, this 4 hours is kind of acceptable for all of our product use cases.
Ultimately, I think Hudi serves as a good foundational data lake to build an AI product on top of, because we have the flexibility to define these large, flexible processing jobs that we wouldn't have been able to as easily do with our previous setup.
Just want to give one last thanks basically to the OneHouse team. Like I said before, they've been pretty invaluable in helping support us, giving us advice on data lake architecture throughout this whole journey. So thanks to the OneHouse team, Vinod, Alexi, Ethan, Suda, and Kyle.